Now that we have learned about cost function, we are ready to talk about some important cost measures. The first one that we have on the next slide is the concept of marginal cost. I'm pretty sure you have seen this thing at the principal level. So let's first recall what it means. So marginal cost is the additional cost that the producer has to take in when it produces one more unit of the output. So if you want to write down a formula that can measure marginal cost, so you first have to introduce some symbols. So suppose when you produce some more, right? So the extra cost is delta C, and the extra amount of output that you produce as a result is delta Q. So then the marginal cost can be written as the ratio of delta C over delta Q, which gives us approximately what is the extra dollar amount that you have to spend to produce one more unit of the output. Okay, now as we have seen several times before, so if these delta terms are tiny, really tiny, so then this ratio can be measured by this differentiation, right? So basically, we're talking about differentiating cost with respect to output. So if we know the cost function, we can differentiate that, and we can, with respect to output, and we can find out the formula for marginal cost. I'm going to show you an example at the bottom of this screen. But first, realize that in the short run, this delta C, right, the change in your cost can happen only when you change your labor employment, right? Or in other words, when your variable cost changes. So as a result, this must be true, right? So your delta C, the change in your total cost, is exactly equal to the change in your variable cost. So we can rewrite this formula by replacing this delta C by delta VC, and we can say that you can find out marginal cost by differentiating the variable cost with respect to output. So these are basically two equivalent ways of finding out the formula for marginal cost. So let me give an example based on the first one. So differentiating the cost with respect to output. So suppose the total cost function is given by this equation, which we derived on the previous slide. So C equals to 32 plus Q squared divided by 4. So based on this cost function, if we want to find out the marginal cost, so we'll differentiate this cost with respect to output. That gives us 1/4 times 2 times Q. So basically this 32 is a constant, it drops out. We're differentiating then this term with respect to Q. So that gives us this 1/4. So this 4 is downstairs, so that's basically 1/4. Then you bring down this exponent of 2, then you have Q raised to the exponent of 2 minus 1, which is just 1. So if you simplify, this boils down to 1/2 Q, right? So that this basically is telling us, based on this cost function, if you are thinking about producing one more unit from whatever output level that you're producing, just plug that amount of output that you're producing currently here, right? And this formula will tell you, if you produce one more unit from that amount of output level, how much extra dollar you have to pay for, right? So suppose currently you're producing 2 units, so plug in 2 here for Q. So it will be half times Q2. So the whole thing will boil down to $1. So that tells us, if you're already producing 2 units, and if you want to produce the third unit, you have to spend $1 more to do that. Okay, so now from marginal cost, let's switch to average cost of production. Recall what's the difference between marginal and average, right? So the marginal always talks about calculation of cost, calculation at the margin, right? So for one more unit. On the other hand, the average measures what's happening on the average, taking everything together, right? So we can think about 3 types of average cost measures. So the first one is average fixed cost, AFC. So this one measures on the average how much money are you spending on your fixed input. So AFC is basically fixed cost divided by per unit of output. So if you think about the formula, right, it is very straightforward, right? So AFC is just F divided by Q. So let me give an example. So suppose the fixed cost is $32, like in our previous example, then AFC will just be 32 divided by Q. And then by plugging in different values of Q, you can figure out what is AFC. So notice something. So as Q increases, AFC, the average fixed cost, decreases, right? So for example, when Q is 2 in our example, then average fixed cost is $32. If you raise the output level to 3 units, then AFC, average fixed cost, falls to $10.67, right? So from $16, it falls to 10.67. Okay, so now let's move on to the next type of average cost calculation, average variable cost of production. So now we are wondering, on the average, how much money are we spending for each unit of output on our labor input, right? So AVC is basically variable cost per unit of output. So again, the formula is straightforward. AVC is then just variable cost divided by Q. So if you know how your variable cost looks like, you can plug that in and then plug in any particular output level that you are trying to produce or you're producing. That will give you the average variable cost of production. Let me give you an example of how we can deal with this. So suppose variable cost is Q squared divided by 4. So this is something that we calculated earlier, right, for our Cobb-Douglas production function. So given this variable cost, I can now plug in Q squared over 4 here in the numerator, right? So then AVC becomes Q squared divided by 4. Then the whole thing is divided by Q. If you simplify this, it boils down to Q over 4. Right? So let's plug in a value of Q. So suppose you're currently producing 2 units. So plug in 2 for Q. So then this whole thing will boil down to 1/2, right? So that tells us that if you're producing 2 units, then you're spending 50 cents on labor for each of those 2 units that you're producing, right? So that's how we can interpret AVC. Okay, so let's now move on to the third type of average cost calculation. So average total cost. So now we want to know, on the average, taking both fixed cost and variable cost together, how much money are we spending on each unit of output? So again, the formula is straightforward. Average cost is just total cost C divided by Q. So if you know how your total cost looks like, you can plug that into this formula. So for example, if total cost is given by this, which we derived in the case of Cobb-Douglas production function, so we have 32 plus Q squared divided by 4, then the average cost in this case would be the total cost divided by Q. So you can break it up into 2 separate parts. So you can divide 32 by Q, and then you can divide the variable cost part, which is Q squared by 4 by Q. So that will give you this thing, right? So the first term is 32 divided by Q. And the second term, where you are dividing this variable cost by Q, that boils down to Q over 4, right? Guys, let me remind you that if you are just copying this thing into your reader right now, that's fine, right? But do these things yourself also, right? So that you know exactly how these calculations are done. Okay, now let's notice something. So recall that the total cost is nothing but fixed cost plus the variable cost, right? Imagine dividing both sides of this equation by Q, right? So you'll be dividing C by Q, then on the right-hand side, you'll be dividing fixed cost by Q and the variable cost by Q. Okay, so you get this then, right? Notice what we get by doing this. So look at the left-hand side of this equation now. C divided by Q is what, guys? So we have this exact thing on the screen right now, right? So C divided by Q gives us average cost. So the left-hand side is basically average cost of production. On the right-hand side, the first term, F divided by Q, right? We have seen this thing before, right? So this is average fixed cost. VC divided by Q, right? In the same way, this is average variable cost. So this is basically what we have in this equation, right? Average total cost is average fixed cost plus average variable cost, and it makes perfect sense. So on the average, the money that you are spending to produce each unit of output is equal to the amount of money on the average you're spending on your fixed input, plus on the average the money that you're spending on each unit for your variable input, right? And I don't even have to give you a separate example. We can see this up here in this example, right? So the average cost is equal to 32 divided by Q. Recall that in our Cobb-Douglas example, this is average fixed cost. And recall that Q divided by 4 is the average variable cost of production. So we have average cost equal to average fixed cost plus average variable cost of production.